Okay, if we take a look at this. If I asked you to find all the zeros and multiplicities of this polynomial, this one is already factored for you to some extent. We've got some ugly things in here, but it's factored. How do you find the zeros of it if it's written in this form? You can, but that would just make more work for you. If you think about this one, once we factored it, how did I find the zeros of this? Yeah, we essentially set them equal to 0 and subtract it over. We got -2 and -1. And so if I were to give you something factored, to find the zeros, we just have to set each piece equal to 0. If I'm asking about the multiplicity, that's asking how many times something shows up. Okay, so you're looking for exponents in that scenario. So if I'm looking at this, we basically figure out what makes 3x equal 0. I need to know what makes 4x minus 5 equals 0. And I need to know what makes x squared plus 3 equals 0. Okay, so 3x equals 0. What would you do there? Divide by 3, and we just get x equals 0. 4x minus 5 equals 0. If you add your 5, divide by 4, you get 5/4. X plus 3, or x squared plus 3 equals 0. If you subtract your 3, to get rid of a square, and with that, plus and minus, so we get x equals plus and minus. What would you have to do with this? So my zeros were 0, 5/4, but remember originally that one had a cube on the outside, so that is multiplicity 3. And then I had my plus and minus I radical 3. Did that have a multiplicity? 5. And you are also welcome to write those separately. You could write I radical 3 multiplicity 5, negative I radical 3 multiplicity 5. And that's also okay. Questions there? All right, so if it's already factored, we can get all of our zeros. Right. We talked before break, let's see if we remember, about a couple different things. In looking at a polynomial, how do you know how many zeros you're going to have? Right, the highest exponent, your degree, tells you the number of zeros. What did the multiplicity tell us about the graph? It's one of those things we wrote down. Yeah, it's a notes handout I printed for you. And there was like a box on it, said the multiplicity of a graph, the shape of the graph and multiplicity. Right. We said that if the multiplicity was odd, so 0 had a multiplicity of 1, 5/4 had a multiplicity of 3, odd multiplicities on our graph, they will just go through that intercept. If it is an even multiplicity, what it will do is hit it and bounce off on the graph. So those are pieces that we've talked about before, but if you've forgotten that, you might want to jot it down. The degree tells you how many zeros you will have. Now, this says it a little bit different. Degree n has at most n real zeros. It will have, whatever your degree is, that's the number of zeros you can get. But they don't all have to be real numbers. some might be real, some might be imaginary. However, when we graph it, can we graph our imaginary numbers? No. So in terms of graphing, we're just looking at the real zeros. And we said multiplicity, odd multiplicity goes through. And even multiplicity bounces. Pieces that we've had along the way. So we're going to summarize the steps that we will go through. On a test or quiz, I'm not just going to give you an equation and say draw a graph. I'm going to give you A, B, C, D and ask you to do these steps along the way. The first thing I'm going to ask you for is the end behavior. Okay, we did that before break. I kind of mentioned it again yesterday. We're going to review that some more today. So end behavior, those are just the two arrows telling me what direction the ends are going. Second thing I'm going to ask you to do is find all the zeros and multiplicities. Third thing, we will decide if the graph goes through or bounce for each zero. I'll ask you to find the y-intercept, and then we will draw the graph. Now the benefit to this, you guys have a graphing calculator, so you can obviously check your graphs on these. I'm asking all this information so that you are going to then turn around and put this information on the graph. So if I ask you to find the exact y-intercept, I expect you to plot the exact y-intercept on your graph. Okay, don't just give me a rough sketch from the calculator. Use the calculator at the end to check your work along the way. So let's go through, and this is all we're going to do today. We're just going to keep practicing problems like this for the rest of the day. Does everybody have those steps down? So we are going to graph 2x minus 1 times x plus 1 times x plus 3. First step, we need the end behavior. To decide our end behavior, we need to think about the degree. If you were to multiply this out, we have 1x here, 1 here, and 1 here, so we have an x to the third. Since the degree is odd, we know it's going to look like a chair. Is there a negative that would flip it? No, so it's going to look like your basic chair. So that means our end behavior would be down, up. Do you guys remember doing that a little bit? And if you weren't sure, you could always confirm that just by graphing on the calculator and making sure you had the right direction for the ends. Okay, what's my second step? Zeros and multiplicities. Since this is factored, all you have to do to find your zeros is just set each parenthesis equal to 0. So 2x minus 1 equals 0. add your 1, divide by 2, you get 1/2. If x plus 1 equals 0, you subtract your 1, you get -1. If x plus 3 equals 0, subtract your 3, and we get -3. None of those had an exponent, so we don't have to worry about our multiplicity. You only have to list it if it's something other than 1. Third thing, for each of these, I want to know if the graph will bounce or go through. All of these have a multiplicity of 1. 1 is odd, so what should the graph do? Go through. I'm just going to say through all of them. You could list it for each one, but since they're all the same, I'll just write it like that. Next, I want a y-intercept. What's a y-intercept? Where it crosses the y-axis. What's true about x if you're on the y-axis? X equals 0. So we're going to plug in a 0 for your x and see what we get out. So if I put in 2 times 0 minus 1 would be -1. 0 plus 1 is 1. 0 plus 3 is 3. -1 times 1 times 3 is -3. Now we draw the graph. Okay, so on this graph, we did A, B, C, D for a reason. I expect you to use that. So I know my end behavior is down up, so it should start down here and it's going to end up here somewhere. My zeros, those are the same as x-intercepts. So I'm going to plot those on my x-axis. We have a +1/2, -1, and -3. I know that my graph has a y-intercept of -3, so I'm going to plot that on my y-axis. Okay, now we can sketch the graph. We know the graph has to start down here because this end is going down. We go through our intercepts. So we're going to go through this one. We have to come back and hit the next one. Hit your y-intercept, hit this one and go through. So I get a graph like this. Now, is my graph 100% accurate? No. I only know my x and y intercepts are correct. For all I know, the graph may look like this. Maybe it went way up here and came down and did something like this. I didn't really measure how high or low. What I am checking when I look at your graphs, do you have the right shape? You know, are the ends going the right direction? This should be a nice smooth curve, so I don't want sharp corners in it. I don't want any breaks in your graph. Did you hit the x and y axes at the correct spots? You could always at the end, good idea if you're not sure, plug that original into your graphing calculator and kind of compare. So why don't you do that real quick and check to see how our graph compares to the actual. Decent enough graph? All right. So a nice thing about these, you can always check yourself at the end to make sure you're on the right track. Any questions about that? So we're just going to keep practicing these today. I'm going to kind of jump around a little bit. I want to do this one next. Okay. First up, let's list our degree and end behavior. If you were to multiply this out, what would your degree be? 5. You have 2 x's in the first parenthesis, 3 in the second. So my degree is 5. So what's your end behavior? Okay. Zeros. What makes x minus 1 equal 0? Positive 1. Since it was squared, that is multiplicity 2. What makes x plus 2 0? Good. Okay, C. At 1, is my graph going to bounce or go through? Bounce. You look at the multiplicity. 2 is even, so it will bounce. What's going to happen at -2? It will go through because the multiplicity is 3 and 3 is odd. So make sure you're paying attention to if the multiplicity is even or odd, not the number itself. All right, y-intercept. If we plug in a 0 for your x's, you get -1 squared times 2 to the third, and that gives us 1 times 8, which is 8. Now we graph. So my end behavior should be down up. I hit the x-axis at -2 and +1. My y-axis at 8. I'm going to count by 2s. So my graph starts down here. At -2, does the graph bounce or go through? At -2, it goes through. So I have to go through this. I have to hit your y-intercept, come down, hit your x, and at 1, the graph will bounce. So that means we just come back up from it. So I get a graph something like this, knowing that it's not 100% accurate, but it's close. Check our work on your calculator, see how we did. It's a little bit, it's got an extra curve in it that I don't have, but we have all the correct stuff. Okay. Any questions there?
So if it doesn't have a multiplicity, it's automatically discussed.
Yeah. If we don't write a multiplicity, it's just like a multiplicity of 1, since 1 is odd, it goes. Okay, let's try some more. All right, so part A, what is the degree here? Let me just think about it. If we multiply it out, we have 5 x's here, 1 here, and 4 here. So it is 10. So what's the end behavior? Up, up. Remember, if it's an even degree, it looks like a parabola, unless we had a negative in front, and that would flip it upside down. Okay, zeros. This x out here, what makes that equal 0? 0. Since it's a 5th power, its multiplicity 5. What makes x minus 3 0? And x plus 4. Multiplicity 4. Okay. Bounce or through. At the 0, what will happen? At the 3. Through. At negative 4. Y-intercept. If I put in 0 for all of my x's, I get 0 times negative 3 times 4 to the 4th, which is 0. So, this one, both ends are pointing upward. Gonna hit the x-axis at 0, 3, negative 4, y-axis at 0. Alright, so I'm starting from the top. At negative 4, what happens? Bounce or through? Negative 4, we bounce. So we're going to come back up. At 0, what happens? Goes through. Okay, you've got to come back and hit your 3, and that one will go through as well. So I get a graph something like this. If we check it, okay. So your calculator, you can tell if you would have to zoom out a little bit. Our graph is a little bit off because it actually goes way up and way down in between there. But that's okay. I'm just looking for the intercepts in the correct spot. So we can see we have the right general shape. We're hitting the axis at the correct points. Okay, is that one all right? One last problem. This one is a bit different because it's not factored for at the beginning. We can go ahead and start. The degree is a little bit easier here. If it's not factored, it's just the highest power we see, so that is 3. End behavior, we know if it's degree 3, it looks like a cube, but the negative in front would flip it, so our end behavior will be for our zeros, we're going to have to find them ourselves. What do all 3 of these terms have in common? X. I'm going to pull out an x. I'm actually going to take out negative x. If I do that, it leaves me with a 2x squared plus an x minus 1. How would you factor this? Box method. So I need two things that multiply to -2 and add to +1. We want a +1, so let's do +2 and -1. So that factors into 2x minus 1 and x plus 1. So now we can see our zeros. What makes negative x equal 0? Zero. 2x minus 1 equals 0. If you add your 1, you get, and x plus 1. Okay, bounce or go through? Through all of them because they all have a multiplicity of 1. Y-intercept, if you plug in a 0, you can do it in the original, you can do it at the factored form. What do you get if you put in a 0 for x? 0. Our graph should start high and end low. The x-axis at 0. 1/2 and -1. Starts up here. And -1 it went through. 0 goes through. And 1/2 goes through. Let's look at this.
Okay, how did you get your NV?
If it's an odd degree, it looks like a chair. And if there's a negative in front, it flips the 2 ends. Anything else? Let's stop there. There is a handout on Classroom. I'm not making you do all of them. We may do a couple in class tomorrow. I want you guys to do 1 through 4 and number 6.